Okay, so this video is going to be about section 8.3. It is the area of circles and regular polygons. So first of all, we've got our area formulas and circumference formula for a circle. Hopefully you remember those. For sure, take this as an opportunity to write those formulas down in your note sheet. Circumference is equal to 2 pi times the radius, and area is equal to pi times the radius squared. Another formula you might want to have written down is just the formula for circumference in terms of the diameter. So circumference can also be written as pi times the diameter because twice the radius is the diameter. It's the same formula, just written two different ways. That might be helpful for you. One thing we talked about in class here was how this area formula came about. And so let's take a look at how that one works. The big thing here that we've got is we've got this circle, and we're going to divide it up into pi pieces, basically. One quick reminder here that the whole entire circumference of that circle is 2 pi times the radius, 2 pi r. So we unfold the circle. We've got half of them up here, half of them down here, and we're going to slide them together, kind of alternating. And you'll notice that this makes basically a parallelogram. So I've got this base here is half of the circumference. So instead of 2 pi r, it's just pi r. This distance is the radius. And so if I were to take pi r times r, well, r times r is r squared. So that'd be pi r squared. That's our area formula. Now, hopefully you're not buying that. This is definitely not a straight line. It's not a parallelogram. But the thing we've got to keep in mind here is if I take more and more and more and more slices, this thing gets really, really close to a rectangle. And you're still probably a little bit unsure. That's still not really a rectangle. But this is where you have to make an argument that we're not quite ready for yet in geometry. And that's this idea of infinity. If I were actually to make infinity slices of this pie, then it would be a rectangle. And we can actually prove that mathematically with something called a limit that you will learn about in pre-calculus. So you're not quite ready to hear the actual 100% convincing argument yet, but this is the basic idea of that argument. And you can see that that formula should work pretty well. It is exact, of course, but you can see where that formula comes from. So let's go ahead and do a couple examples here. So first off, finding the area of a circle. We're going to leave this in terms of pi. That's something you maybe not done before. So if I have the formula area equals pi times the radius squared, I just plug in my radius, which is 7. And the best part about leaving this thing in terms of pi is I don't really even need a calculator for this. I know that 7 squared is 49, and all I'm going to do is just write the 49 first. The commutative property of multiplication says it doesn't matter which order I write these in. And so I can write the 49 first and the pi at the end. That's no problem. Inches squared, and that's your answer. You don't even need a calculator to do that. Just take 7 squared and you got it. Now, you, of course, are going to have to be able to work backwards on these. And so here we've got find the radius of a circle with an area of 21 inches squared, or 21 square inches. Be careful. Some of these are going to be just 21. Some of them are going to be like 21 pi. It's going to change your answer. So make sure you're actually reading what the question says and not just what you want it to say. So again, I know the area and I want the radius. So I'm going to use the area formula. I'm going to plug in what I know. And then I can start working on solving for r. Here I'm going to divide by pi. Divide by pi. It'll cancel out there and give me r squared. On this side, though, this is one place where we're probably not going to leave it in terms of pi. I don't want to deal with 21 divided by pi, so a calculator can help us out here. So I'm just going to do 21 divided by, there's a pi button there, or you can just type pi on your keyboard and it'll tell you the answer. So I get 6.68. Now at this point, I am not rounding this value. I am leaving this answer stored in my calculator for now. I'm going to write 6.68 on the paper, but when I actually go to do the next step, I'm not going to use 6.68. So the final step here is I need to get rid of that squared. So I will square root it. That gives me r on this side. And on this side, again, because I have this value in my calculator, I'm not going to type square root of 6.68. I'm going to type square root of the previous answer. That is going to make sure that I'm not rounding this thing way, way off. And you'll see how bad, I'm going to show you at the end of this how bad you could get an answer if you tried rounding it off. So square root of that is 2.585. So I'm going to write 2.59 as my radius. And now I'm still storing that value in my calculator. That's inches. Now the next step of this is, can you find the circumference from that? Well, the circumference is going to be 2 times pi times the radius, or in this case, 2 times pi times 2.59. I'm not actually typing 2.59 in my calculator because I've got the value stored right here. I'll hit enter, and now I can just type 2 times pi times the previous answer, and I get 16.24 as my circumference. Because I ended up with a decimal here and here, there's no point in trying to put it in terms of pi here because I still have just a decimal times pi. And the whole point of terms of pi is exact answers. If there's a decimal that we've rounded, there's no point in putting it in terms of pi. So let's just take a look here and imagine that I did round these off. So I did 21 divided by pi. I got 6.84, and I'm going to assume that I'm not using the previous answer. So I'm going to take the square root of 6.68. You'll notice here that actually would round differently. Instead of rounding to 2.59, that just rounds to 2.58. And then when I go to plug it into my formula here, 2 times pi times 2.58, I get 16.21 instead of 16.24. That's the rounding error that you're seeing there. So whatever decimal point, if you're going to the hundredths, you're going to notice that difference, and that's going to look, you got that answer wrong, and you did. You rounded too early. So don't round. If you're ever in a situation where you've got decimals that you'd have to round, use the stored value in your calculator. Every scientific calculator can do this. If you don't know how, make sure you ask. But here you've seen it on Desmos. Last thing we got to talk about here is the area of a regular polygon. And hopefully these pictures kind of give you an idea of how we might do that. We're going to break these things up into triangles. If you could find the area of each triangle, you could just multiply by however many there are. Now, a couple of things you're going to see. We give these things slightly different names in this case. So where this would normally be the base of the pentagon, or the base of the triangle, we're calling this S for the side length of the pentagon. Where this would be called the height of the triangle, we're calling this the apothem. It is the distance from the center perpendicular to the side. But remember, those are the base and height of your triangles. And then to find the whole thing, we just multiply by however many there are. 1, 2, 3, 4, 5 in this case. That one's got 7, whatever that happens to be. So the formula we're going to end up being able to use here is 1/2 times A times S times N. A is the apothem, that's like the height. S is the side length, that's the base, the 1/2 for the triangle. N is just the number of sides. And so that's exactly what you would think it is. It's find the area of the triangle, multiply by the number of triangles. Now, one thing we can do to make this a little bit nicer in some cases is to take this S and N. S is S is the length of the side, N is the number of sides. If you multiply the length of the side times how many sides there are, that's the perimeter of the shape. And so we could also write this as area equals 1/2 the apothem times the perimeter. And there are situations where it's really nice to have that. So go ahead and write that down. And make sure you've written down what those letters stand for. Maybe draw the picture and write this down, because if you get to the test and you go, oh, 1/2 ASN, what's A? It doesn't make any difference if you wrote the formula down, if you don't know that A is the apothem and it's that thing. So pause the video if you need to write those down, and then move on when you're ready. So one example here I think is all we're going to do. A regular polygon has an area of 120 square inches and an apothem of 6 inches. What is the perimeter of the polygon? So we're actually using one of these formulas backwards right off the bat. Here's a big thing to think about. In this question, they are telling us the area, they are telling us the apothem, and they are asking for the perimeter. The formula we pick needs to have those 3 variables in it, and it can't have any more. And so we need to definitely use this second one here. Area equals 1/2 AP. And so I'll plug in what I know, 120. equals 1/2 times 6 times p. At this point, a good strategy would be to simplify what we can. Since we've got 1/2 times 6 here, I might as well just do 1/2 of 6. That is 3. And then I can divide by 3 on both sides. And that gives me my perimeter. 120 divided by 3 is 40. And since my area was in square inches, my perimeter will be in just inches itself. And so there you go. Real quick here, just one example of using that formula forward since I didn't get a chance. We did these in class together. If I'm trying to find the area for something like this is number 9. I've just got my formula. Area equals 1/2 times A times S times N. I'm just going to plug in what I know. 1/2. The apothem is 24.9. The side length is 24. Tells me that right up here. And if I count those sides, I believe, make sure I get the right number of sides here. I believe it's 7. So 1, 2, 3, 4, 5, 6, 7. It is times 7. Now, you can certainly work your way through, multiply, multiply, multiply. But again, if you have a scientific calculator, any scientific calculator at all, it makes it a lot easier. You just type in exactly what you see, and boom, there's your answer. 2091.6. Depending on the directions and how you round it, I think this one says to the nearest unit, nearest square unit. So that'd be 2092 square centimeters. And so that's using it forward. Assuming you're using a calculator, it's really pretty easy to use that formula forwards. Okay, so you've got the rest of the homework here. A little bit of a jumping around, but that's just so you don't have to do a ton of questions. So stuff with circles, stuff with polygons, and then these last ones are a little bit more of a challenge. So you've got this circle that's had a rectangle cut out of the middle and an octagon where you only actually are looking at 6 of the sides, not the other 2. So think about how you might do that one. And other than that, I will see you later.